So good evening everyone, welcome back to this live interactive session. This is week 11. Myself Suman Ganguly, I am a PMRF research scholar from IIT Kharagpur. I hope the screen is visible to all of you, and happy Dasera and also happy Durga Puja for everyone. Can you again confirm that is it visible or not? I hope it is visible. Is it? Can you please confirm that you are able to see my screen? Hello. Am I audible also or not? Hello. Am I audible? And is my screen visible? Okay. So then let me start the session for today, right? Okay, this is a kind of mix of theory and numerical ones. So initially these questions will be attempted by the participants, right? And then I will also brief about the uh, correct answers, and then also we will solve some of the numerical questions, right? So first question is, which of the following input data element falls under traffic characteristics data category, right? So is it number of through lanes, or is it total walkway width, or is it uh, dual time, or is it width of bicycle lane? So which of the following data elements falls under the category of traffic characteristics? So if you I hope you have already seen the course material and also go through the video lecture series for week 11. So you would have known that there are some kind of input data that was needed. It is based on 2-3 categories like geometric design and the facility design, then the traffic characteristics. So it is talking about those things. So which of the following input data element falls under the traffic characteristic data category? It can be multimodal, it can be unimodal, whatever it is just a data category. So I hope it is I hope you will be able to answer it. Say number of through lanes or number of lanes also you can think it like 1 second, whoever is joining. So then is it the total walkway width, is it dual time, is it the width of bicycle lane? So now tell me which of among these four, which of this category is falling under the traffic characteristics? So you may answer or comment in the chat box that whether the answer will be A, B, C, or is it something else. So what do you think? What is the traffic characteristics data type among these four options? I am getting some answers. I think A. I got one answer. He is saying A. Okay, number of through lanes. You are thinking that it is falling under traffic characteristics. Okay, can I get some more responses? Uh, and whoever is there, can you please mute your microphone, because I think it is background noise are coming. Just mute it. So also number of through lanes. Okay, so maybe I should consider discuss it since I got two responses. So no, now the thing is number of through lanes. So how many number of lanes is there? It is falling under geometric design. So what is geometric design? So geometric design means like how many lanes are there, what type of lanes are there, what is the width of those lanes. So these all are falling under actually geometric design. These are all geometric design, not traffic. Traffic is always kind of, so if you think geometric design, so if you have a lane or if you have a road that has two lanes, so generally before expanding lane, say if someone is not expanding your lane, which is not possible every time, it may be done after after certain 2 3 5 7 years based on if this space is available or not. So this kind of number of lanes and the width of lanes generally don't change with time, or you can see that after you built it for a fixed number of year it will not change. So those are geometric features, it won't change. And the traffic characteristics, those are spatio-temporally variable. So what do you mean by spatio-temporally variable? Suppose here the example is dual time. So what is dual time? So dual time generally means the time taken by a bus or any public transport mode like train, bus, to serve the passenger. So when we are waiting for the train and the train comes and we basically board and some people also alight, right? So that time is dual time. So if you see, if you have a major station and if you have a minor station, right, so you see that dual time will change, right? Your dual time cannot be same, because if you have a major station you have more people standing there and more people want to alight also, right, deboard. So then your dual time is changing between the space, so one station to another station it is changing. Also if you think that during the peak hour or the hour when the passenger demand is highest, that time the dual time will be more. And if you see in the afternoon hours, like after 12 to maybe 3 or 4, and also the morning time before 7 or before 8, that time also your dual time will be less because your number of passengers will be less, right? So this is saying that it will be traffic characteristics, it will fall under traffic characteristics because it will change with time, right? Geometric features usually don't frequently change with time, it will be a fixed thing, right? So the correct answer would be this C, not this, not this, not this, because these are geometric. Width of bicycle lanes, obviously width is geometric, number is geometric, walkway width also geometric, right? So then let us go to the next question. Which of these following is least favor in MMLOS, like multimodal level of service calculations? Which of the following is the least favored? So already you familiar with this multimodal concept, right? So you have not only bus but also auto rickshaw, but also your bicycle, then your pedestrian facility, right? Then also sometimes car also, right? So then if you want to develop or if you want to plan for this kind of multimodal facility, what do you think will be the least favor, right? So it will coming at the last, so you want to give the least priority to which of these modes? Is it the auto, is it the bicycle, is it the pedestrian, is it the transit? Transit means your bus, trains and those, and the pedestrian means us, if we are walking, that's a pedestrian thing. And is it the bicycle, it is the auto, you can consider auto or kind of auto rickshaw, or you can consider it as maybe your car also, right? So So then tell me which, what do you think will be the answer, right? Tell me, I will wait here, right? I want answer from you, I think. So what is least favor? You are saying Chandan is saying A, okay. Also Sumitro is saying auto, okay. Okay, so actually you are correct. It is the auto or any kind of motorized mode, because we don't want to promote the motorized mode of transport, right? Rather we want to promote the others mode of transport. And here also, if I would have asked you that what would be the least what would be the most preferred mode of transport that we want to incorporate, it should be the pedestrian. Then it will come to your bicycle, then it will come to your transit, right? And at last you will get your auto, right? So okay, let us go to the third one. So which of these facility, which of these are the facility design elements? So it could be multiple answers, like more than one answer also is feasible. So what do you mean by facility design elements? So which of these elements are the facility design elements? Facility design elements. So you have a facility, suppose you have a bus route, that's a facility, right? Or a transit route, any metro route, any rail route, anything. So then your facility design elements are which elements? Is it the lane geometry? Is it the bus stop? Is it the speed limits or speed limit signs that we put in the on the roads, right? Or even on the railway crossings? And is it the signal control? So what do you mean by this facility design elements? So what would be the facility design elements, right? So I will also wait here also for your response. So as I have told you, it may be one or more, I don't know, but it may be one, maybe more. So what do you think, which of these are the facility design elements? So what is a facility? A bus route may be a facility. Then what are the design elements? So there are two things, one is the facility control, another is the facility design. So you need to think what is falls under the facility design and what is actually falling under the facility control. Facility design elements. So if you want to design a bus route, what are the elements you need? If I break it down, it means this. Say if I want to design a bus route, which is a facility, which are the elements for that I need to design? What is the essential elements of a bus route? Why do you need a separate bus route? Because already you have a road, so why do you need a bus route? So there are certain things that you need to incorporate, right? What could be those things? So you can try to give answer in the chat box. See, okay, I got one response, is the lane geometry. Okay, I will wait for some more responses before I start. B, A, okay. So all of you are correct, but both A and B actually comes under facility design elements. So you may think that okay, bus stop may come under the facility design elements, but how come the lane geometry? So the thing is, so how many lanes actually do you need for your bus to run? that's a thing that you need to design. So is it the mixed lane? What do you mean by mixed lane? Mixed lane means your bus will run on the existing lane, whichever existing lane is there, and there maybe bicycle, may not be bicycle, maybe motorized different modes like autos and cars are already moving, and you want your bus to run on the same lane, right? So then that geometry will matter, right? Or as you would have already known those BRTS systems like bus rapid transit corridors, wherever they are actually, you have a dedicated separate right of way, right? So there also how many lanes, for how many lanes, and what is the width of the lane, so those things has to be decided, right? So lane geometry as well as bus stop, these are the two things, those actually coming under the category of facility design elements. So then what is the facility control also? Facility control means, so you have a facility, you want to have some controlling elements. So as the name suggests, so if you have a signal, so actually it is controlling your flow, right? You want your vehicles to stop, you want your pedestrians to stop. So basically it is controlling your facility. So that's why it's called a facility control. Also speed limit. What is the use of speed limit? Speed limit also tries to reduce your speed, right? Or contain your speed to a certain limit. So it is also kind of controlling your elements in the design. So there are two things, one is facility design, one is facility control, right? So we will go to the next one. Okay, so this is a problem. Determine the automobile level of service for a west to east direction facility using HCM 2010 methodology, and the individual segment length is given, base free flow speed is given, travel speed is given. Also I have given you the HCM 2010 chart which you can use to calculate your LOS. So I want you to calculate the LOS of this facility, considering we have a 3 segments, right? Of a facility we have 3 segments, and then we want to aggregate it, and we want to calculate the LOS of the entire facility, right? And there are two parts. First part is your B/C ratio is given as 0.78, and the second part is, if your B/C is not given, then how would you calculate your level of service in this context, right? You can start calculating, as well as I will start calculate, right? Because I don't know what is the answer, so you calculate, then we will actually see what would be the LOS of this facility, right? So what you need to calculate is the weighted base free flow speed, because the segment is given, and based on the weight we want to calculate the weighted base free flow speed, right? Or weighted average base free flow speed. So you can calculate, it is not a difficult task to do. Plus 55 into 0.78. If you got the answer, you can uh, comment on the chat box what is your answer. I am also calculating. If you finished your calculation, then you can comment. So first you need to calculate your base free flow speed, then you want to calculate your travel speed, then you need to calculate your travel speed as a percentage of your base free flow speed, then you have V by C is given as 0.78, means it is less than equal to 1, then you need to see that what is your LOS. So do you finish your calculation? If yes, then respond. What is the value? What is the, you can tell me what is the weighted base free flow speed, weighted average base free flow speed what you got, that is SF0 average, and then what is the travel speed, means the weighted travel speed you got. You can tell me what is the no, you do not want to respond. So how to calculate the this 45 into 1.85 plus 55 into the length 0.78 plus 65 into 0.95 total divided by 1.85 plus 0.78 plus 0.95. So total is 3.58. 3.58. So it will come what, I think 52.48 or something. Let me calculate once again. Plus 55 into 0.78 plus 65 into 0.95 divided by 1.85 plus 0.78 plus 0.95. So it will be 52.486, means 52.49, right? So here the value is 52.49. 52.49. This is the value of this weighted. And the travel speed, then what is the travel speed weighted value? 15 into 1.85. Similarly 15 into this, right, 1.85 plus 25 into 0.78 plus 10 into 0.95, right, divided by 1.85 plus 0.78 plus 0.95. So this is comes as 15.85. So it is 15.85. So 15.85 divided by 52.49 into 100. This is 30.19. So if you divide your 15.85 divided by this value, you will get a value is 30.19 or 20, whatever it is. So it is not, it is comes under this 30, and less than 1 LOS means your LOS is LOS E. And if your V by C is not given, then it is very difficult to calculate, since you are greater than 1. If it is greater than 1, then it is F. It is less than 1, then it is E. So you cannot surely say that what would be the LOS. So you need your V by C ratio to be given. If it is not given, then I don't know, it may be E, it may be F also, right? But if it is less than 30, then whatever the your V by C is, we can say that it may be this or this, because both are F, right? So like, is it so do you able to understand it, this whatever I have shown you? Okay, I got your could not do it, but do you understand right now? Right now, can you do it, or maybe can you say that okay, I will be able to do it afterwards? Just you need to calculate your weighted thing, right? Then you need to divide your weighted base free flow speed with your travel speed, right? Is it okay, right? I think you will be able to calculate further. So then if it is yes, then I will move to the next one, right? So can you just again tell me that okay sir, go ahead to the next question, then I will. Okay. Okay. So this is the next one. So this is also a numerical one. So what is, determine the travel time ratio, level of service, as well as the interconnectivity ratio for a metro system between two origin destination pairs, okay, whose riders had the following average value of travel times, right? Okay, so you have this data. Let me select my pen. So you have this data, right? You have this access time, egress time, transfer time, wait time at transfer point, IVTT, that is in vehicle travel time, right? In vehicle travel time of any public transport. Here it is metro. It is already been given that it is metro, right? So in vehicle travel time in metro, and the time taken while the journey is done by car. So now first is the travel time ratio. So what is the travel time ratio? TTR. You will calculate, I will just tell you the formula. So the travel time means the time took if I made the journey using public transport, that is metro, and if it is done by car, what is the travel time? TT means travel time. Now you can calculate the TTR, because it is nothing but travel time of public transport and the travel time of car. So what is that ratio, right? So you have in case of public transport, so your time is not only in vehicle travel time, but also your access and egress time, right? What is the access time? So suppose if I want to take a public transport for a particular station, from my home to my station there is a distance or there is a time. If I take any mode, or if I go by walking, so I have that time, that is called the access time, right? And whenever suppose I am going for my workplace and I went down to a certain location B, then also from B to my workplace W I need some time to go, right? That is called egress time. So the total time, that is called the access time per egress time plus in vehicle travel time by your, that is called your total journey using the metro, and then your travel time by car. So that is called the travel time ratio, right? So you will calculate. I will just write the formulas, right? Only you will calculate. Then only I will calculate. So then your level of service and your interconnectivity ratio. So your interconnectivity ratio, right? So what do you mean by interconnectivity ratio? So your interconnectivity ratio is nothing but your access time plus egress time, that is the interconnectivity time, divided by your total time in public transport, that is called your interconnectivity ratio. And what is your LOS? LOS is your A plus your E, means the access plus egress, by your in vehicle travel time. So the thing is, suppose your in vehicle travel time is 20 and your access and egress time also is 20, then your LOS is 1, right? So that's the thing. So now you I think you will be able to calculate. Can you calculate and tell me? Also I am calculating, so you also start calculate and tell me which of the answers will be correct, because I have also told you the formula. Okay, I got my TTR. I hope you will also get your TTR. Okay. This is TTR, and then what is your level of service? Okay, level of service is this. Okay, so I got my level of service as well, and then what is this? Okay, 20. Okay, okay, by okay. So I got my values. Can you also respond if you got it, or if you have also some difficulty, and then also you can ask me that I will again describe it. TTR is equal to 1. Okay, you calculate all the three values, and then you tell me what would be the answer A, B, C, D, right? I will wait for some time, like I am giving you the time for calculation. So you calculate and then tell me. So indeed your TTR value is correct. So you are going in the right direction, Sumitra. So you can calculate rest of the two parameters, level of service and your interconnectivity ratio. LOS is 1.04. Okay, then the next one. Interconnectivity ratio is 0.51. So then your correct answer would be C, right? 1.7, 1.04 and 0.51. So what about the other participants? Like can it be done, or should I or like I need to make it more clear, or maybe what is the scenario? If you can say, then it will be helpful for you also or for me also to understand, because it's nothing but the formula. But if you have some difficulty in understanding the formulas, or because I am writing using this pen in the PowerPoint, so the writing is not good, that I understood. So if you say that you will be able to calculate, the answer would be C. Then I will move to the next question, right? So we can do, okay, that's all right. So I will go to the next one. Okay. So now okay. So now this is the question number 6. A group of expert and stakeholders are provided with a list of possible park and ride facility locations at ABC. So you have three most probable park and ride facility locations, that is with you, right? It is the possible location. So you want to design a park and ride facility. So you have three possible potential locations, right? So now as a transport planner, you want to use not 6 criteria but the 3 criteria. Sorry, it is not 6, it is 3. So first one is transit type, and then the passenger volume, and then the fare structure. So based on this 3 criteria, you want to see which location actually you want to select, right? So you have 3 locations, but based on these 3 criteria, you want to select which would be the potential best location for you, right? For as a transport planner. So then analytical hierarchy process, you need to use it to help the transport planner to select the best facility for the implementation, right? What could be the best facility? So also determine the most important criteria. So then first question is, what is the best location, right? In terms of A, B and C, which of the location that you want to select. Also determine the what could be the best criteria. So what is the best criteria? Your criteria is it transit type, is it passenger volume, is it fare structure? So that's called your criteria, right, for selecting the location. So how do you do it? So generally what we do, we have 3 locations A, B and C, and for each location we kind of give questionnaire survey, pairwise questionnaire, to see for each location how people perceive that the different thing, transit type, passenger volume, how those things are varying, right? So based on that, because your criteria is 3, transit type, passenger volume and fare structure, so you want to weight them, you want to calculate the weight of each criteria, right? So here what I mean by this is that you want to calculate the weight of these 3. You want that which criteria weights how much, that is your weight. And then you want to calculate, because for each weight or for each criteria, for 3 locations you got this value from your questionnaire survey, like your pairwise comparison, and you got these values. So now you want to calculate what is the average scores of each location for each this uh, criteria, right? And then if you know that for this location and for this criteria I know what is the average value of importance, and then for B and for C, then based on the weight of that facility we will calculate it. So like I am here I am just describing how to do it. So first you just take the sum here, right? So if you take the sum here, so it is 6.25, right? 6.25, and then here it's 5.14, right? 5.14, and here the sum is 8.2. So now you want to divide your 1 by this, you want to divide your 2 by this, you want to divide your this by this. So now you what you will get is something like this. So if you divide it 1 by this, you will get a value. Suppose this is comes out to be 0.16, and then it will come as 0.04, and then the third one it will come as 0.8, right? So now for TT we got these three values. Now for PV we know that is 5.14, right? And then 4 by 5.14 is comes out to be 0.778. Now the second one is 1 by 5.14, 0.195. Then the third one is 0.028, right? So for this and this we got. Now for the FS or the fare structure we want to calculate it. So for 0.2 by 8.2, so it will come out to be 0.024, and then your 7 by 8.2, it will come out to be 0.854, and your third one will be 0.12, right? So now if you take the average of this 3, average of this 3, and the average of this 3, and the average of this 3, average row wise average, right? R is row wise, row 1 average, row 2 average, row 3 average. So now you know what is the importance of, or what is the weight of this TT, what is the weight of this PV, and weight of this FS, right? So now if I just go here and erase this values, then okay, so then sorry, then pen. So then my weight for this TT and PV and this will come out to be, for TT it will be 0.3206, for PV it will come out to be 0.363, and for FS it will come out to be 0.32. This is the weight of TT, your criteria 1, your criteria 2, and your criteria 3, right? So nothing, just you need sum and then you divide each value with the sum, right? It's a kind of percentage for each what is the contribution. So now as you do it for this, you want to calculate for this separately, for this and this. So if you do it finally, so for TT you will get a average value of A, average value of B, and average value of C. For TT you will get, right? And then for PV you will get average value of A, B, C, and for FS also you will get. So now if you know the weight of TT, so if you add your A value to your weight value for B, A, B and C, and for your this and this, and then you add up, then whichever the value will be given you the highest value, that will be your main location which we want to choose, right? So here also, from here you decide your this value is important, this criteria PV, passenger volume, is important than your transit type and your fare structure. This is the most important criteria, right? Here you, if you see the value, this is 0.36 and these are 0.3232, right? And from ABC also you will be getting a answer. So now I know it looks complicated, but it is not complicated at all, right? So can you tell me that you can do it? Because already I told you that your preferred criteria is PV, so your answer will be lies between A and D. Either it will be A or it will be D, because your most important criteria is PV. Also you can try actually calculating the uh, this, whether you can calculate your PV, FS and TT. Since I have already calculated it, so maybe you can try calculating and see that whether your answer matches with my answer, right? So what will be your preferred location? So how do you calculate it? Hmm. It can be done. I receive one answer. Then what about the other Soumitro? Soumitro. Okay, it may be the correct answer. I don't know, because I need to also calculate. It will be A or it will be D. So do you calculate? Means did you calculate it? Then like, or you are just guessing? Because it will involve some calculations. So I leave it to you that you calculate and then you can tell me, because the calculation has to be done. Other thing is not very difficult. And if you want me to calculate, then you tell me, I will calculate it. If you think that it is necessary for me to calculate, then I will do it right now only. Otherwise I will skip it and I will leave it to you that you calculate, but it will be A or it will be D, either A or D. Tell me what you want, Sumitra. Okay, I think you will be able to calculate. That's not a problem. Okay, so this is what are the benefits of park and ride facility. So what is park and ride facility? So suppose you are coming from a suburban area which is not entirely falls under the urban area, right? You will coming from a suburban area to the urban area, and now suppose you have a transit center, or suppose you have a parking facility, like a good connectivity, good accessibility metro station, where you have a parking facility. So you want to park your vehicle there, then you take the metro and then you reach your place of work, which is located at urban areas, right? एकदम core of the urban area, like a CBD area. So then what could be the possible benefits of a park and ride facility? Like if I design a park and ride facility, then is it that it will decrease the congestion on road, and is it the increase the fuel efficiency of my vehicle, or is it that the emissions will be less and the air will be more cleaner, so it has some environmental benefits? And whether passengers can also improve their work time management while traveling, since they do not have to drive their vehicles by themselves, so now they have a public transit vehicle, so maybe they can work, because uh, generally your good uh, if you want to develop a good parking and ride facility, then your uh, metro or other kinds of the systems that is there, so though they generally have Wi-Fi and all, so you can connect to the Wi-Fi and the internet and you can do your work. So what could be the benefits of the park and ride facility? What do you think? You need to think it like that, that why it will decrease the congestion, why it will increase the fuel efficiency, why it is having some environmental benefits. If you think it like that, then you can answer it, right? So tell me, what are the benefits of a park and ride facility? Okay. Okay, I got one response from Sumitro, that environmental benefit. So uh, while the other person will also answer, so let me ask you one more question, that if it is having the environmental benefits, so why it is not decreasing congestion on roads? because if I do not have the park and ride facility, maybe the commuter is end up reaching the urban area somehow or close to the urban area by his vehicle. So then it will increase the congestion also on road, right? And then because he is not using it, so then it is having some environmental benefits also, right? And also just think that park and ride doesn't necessarily means that it is only the metro. Here they are also maybe shared cab or shared transit systems, those are also there, right? Like a bus or those systems, right? So the thing is, so suppose uh, I am just parking my vehicle on a park and ride facility, then I am waiting for my public transit vehicle or maybe some kind of shared shuttle kind of thing, right? Then actually it is helping to decrease the congestion as well as increase the fuel efficiency of not only my vehicle, because if I drove with my vehicle on that road, due to the congestion my fuel efficiency, because I will stop and go because of the high level of congestion, right? So it will my fuel efficiency will be lower. So then if I am not using it, so obviously decrease congestion means it will increase the or improve the fuel efficiency of other vehicles plying on that road, right? It is not that every vehicle is are not plying, some vehicle are plying and it will increase the fuel efficiency of those vehicles. And then obviously it will have some environmental benefits, because you are not emitting those toxic gases anymore, right? Or because of the less number of vehicles. And also it is improving a commuter's time management by working while traveling, because now you are not driving. So if you have a own vehicle, generally in India we are seeing that we have a driver, but after a while you are only drive your vehicles. So if you are driving your vehicles, and now if you have good facility in your metro station as well as your public transport, so you can connect to the Wi-Fi if you need, and then you can do your work there while traveling also. So in this particular scenario, although I have given question like that, but it will be A, B, C, D. Everything is a benefit of this park and ride facility, right? So then that's all from my side. If you have any other queries regarding the course content or anything, you can ask me, and if not, then we will meet in the next week, that is the 12th week, and it will be the final week for this course. And thanks for you people that you joined, and we interact, and we try to teach you as far as possible. So tell me if you have some queries, or we will wrap up the session for today. Shall we close it? Okay. Okay, thank you, Sumitra.